Okay, I'm gonna go kind of fast here because I want to do a lot in this project. Okay, so I'm gonna start out with a constant here, and I'm gonna call this res. This is gonna help me decide how many particles I'm gonna have total in my simulation. And then I'm gonna go with a keyboard in and rename it. So this is gonna be my reset command. I'm gonna merge these into another chop, and then I'm going to make a null, call it variables, right click and hit view, and I'm going to move this up to the top so I have my variables easily found. Okay, I'm going to add a couple more things here. Let's also add a count to my reset. So, and this is going to be renamed to my seed to add some variability to my noises later on. So now as I hit 1 to reset, it increases my seed. Okay, what else? I'm going to, okay, I also want to take this resolution and use a function. This is going to calculate how many particles I'm going to have. I'm going to use this resolution for the width and height of my texture for all my particles. So the actual number of particles is going to be that number squared. So I'm going to use this input to the exponent power, and this is the exponent, so this is going to be squared. So this is going to be renamed to my particle count. Okay, merge that in. So I've got that up here as well. All right, what else do I need? I'm also going to add a speed control as well, so that I can adjust that later. Okay, so now I've got my basic constant set up. Let's go ahead and start setting up our particle texture data. So I'm going to start with the noise, and I'm going to set the size based on this res. So I'm going to grab that, send it to the resolution, and reference it. I'm going to change it to not be monochrome. I'm going to change it to random, and I'm also going to, let's go ahead and attach our seed. And let's make sure this is a 32 RG, because this is just going to be my X and Y data. I'm going to change it to nearest pixel. Okay, that's my starting positions for my particles. I'm going to drag that into a null and call that start position or start pose. Okay, change that to nearest pixel as well. Okay, so that's my start position. The next thing I'm going to do is add another one for my vectors. So I'm going to create, actually I'm going to use the same noise for now, just copy and paste it. I'm going to drag this in here and just use my input to set my resolution. And then I'm going to add 1 to the seed so it's not the same. And since this is going to be a vector value, I want it to go negative and positive. So I'm going to offset it from 0, and it'll go negative and positive point, or a range of negative 0.5 to positive 0.5. Okay, so this is going to be, I'm going to add that to a null, call that my start vector, start vec. Okay, so this is kind of my starting information here. Now I'm going to start my feedback loops. So let's have the start position go into a feedback loop. Let's bring in our reset to the pulse. So now resets the feedback anytime I hit 1. Change that to nearest pixel. And let's also make a feedback for our vector. Do the same thing. Have the reset. Set to nearest pixel. Okay. Now I'm going to start building my calculation. So this is the trickiest part of everything here, is that if we're doing a flocking algorithm, there's a couple rules that we want to try and follow. So we want to attract our flock, or attract our particles towards each other, but then within a certain range, we want them to repel each other. So we want to say get close to each other, but not on top of each other, right? So that's kind of going to be step 1, is doing that part. Then there's the third part of it, is we want them to follow each other. So as they come together, we want them to start heading in the same direction as each other. And then yeah, those are the 3 main rules of flocking, and then we're going to add some more in the future here. So The way we're going to do that is we're going to use an instancing network to kind of create a force map of where all the forces are currently in the space. So this will make more sense. If that doesn't make sense, it'll make more sense here in a second. So let's add this to a null, and actually we'll do another null in between, and we'll collapse it just to create our ins and outs for us. And we're going to call this push pull. So I'm bringing in my position information, and I have an output. This will change what that'll look like in a second. Okay, so I take my input data and my output data. I'm going to delete this for now and disconnect this for now. Okay, so I want to take my positions. I'm going to bring this in. I'm going to a null and call it position, and I'm going to make a render network here. So I'm going to start out with a circle, and I'm going to shrink this down to, I think, 0.04. Let's do that. I think that's about a good space if I remember correctly. Okay, bring that into a geometry. Bring in a camera. Since we're using UV, and I know I'm going to want to keep it flat, I'm going to do orthographic and bottom left and ortho width of 1. And I'm going to use a material. I'm going to grab a constant, drag it on there, and then a render. And this is kind of good just for the simulation, but to keep things simple, I'm gonna make it 1000 by 1000, a nice square render output. Okay, and that's gonna lead to where my output is. We're gonna change a couple things here as we go as well. Okay, so what I want to do is for each of these positions, I want to make a force. So I know that for each particle, I want to attract things toward me, but if they're too close, I want to repel them. So we're going to make a sort of gravity well sort of simulation here. So I'm going to use a ramp and change it to circular. And let's see. And I'm going to change it to hold. Now, the way this is going to work is we're going to be attracted towards the white areas and repel. And yeah, we're going to be attracted towards, the force is going to go towards the white areas. So, you know, if anything is around this, it's going to be attracted towards this middle point. That's what we want for our, we're going to say this is going to be our attract force. And then for my repel, yeah, so null, and I'm going to call this repel. The way we want this one to work is we want to be move away from the middle and yeah, stay from the outside. So okay, I'm actually going to end up adding these two together. So I'm sorry, this might be more confusing if I'm doing this in a weird order. So let's take this back up down. Okay, so let's add these together, and let's also let's change some of our periods here. So this, I'm actually holding this black value, and I'm going to be using the slope of this to calculate the forces. So I actually want that gradient to start on the outside. So I'm going to grow this period until I notice the gradient is starting from the outside, so that the slope is coming the entire way through. And then sort of the opposite of this, I'm going to shrink it down because I only care about it being on the close side of it. All right, and then let's bring in, to help me kind of visualize what I'm doing here, I'm going to use a top to chop and take a look at our data here. So okay, so right now it's all flat because we're maxing out at 1. So I'm going to change both of these to be 32-bit float, or 32-bit mono. Actually, let's go and do that. Okay, so now we're seeing, okay, I've got this sort of ramp up and ramp down, and I only need this to be mono. This is mono, yeah. So let's get rid of all those extra values. Okay, and you kind of have to imagine this upside down. So we're going to have a sloped in, you know, from a certain distance slope in, and then if you're too close, it's going to push you back out. So this is kind of the sweet spot where this is going to be pushing the particle in its area. So this is where each flock particle is going to be pushed in relation to a single particle. All right, let's keep moving. So let's add this to a slope. And then I'm going to have that go from 0. I'm also going to use the green value instead of the blue, so that way I can just have a 32-bit RG, or sorry, 32-bit RG. And if I hit A and N, this is my favorite new thing, is to look at the normalized values of each channel. I see, okay, great. I've got slope value different for my red and blue, or for my red going left and right, for my green going up and down. But you'll notice that the max values are very small. So I want to kind of keep everything normalized. So I'm going to use the limit, and then I'm going to say normalize. Okay, so now I have this nice clean, red and green slope vector that I'm going to use as my texture that I'll render around each particle. So let's add that to a null. And then let's add that to our texture. Now, well, let's go ahead and finish our instancing on the geometry first, and I'll talk about this next part about blending. Okay, so let's change this to nearest pixel. So if I go in here and I'm going to set my position based on my input here. Okay, I've got all my pieces, but you'll see there's overlap. So obviously I can't have these overlapping, or there's going to be overlap, but I need some opacity there, and I need to make sure that the opacity allows all the information through. So I'm going to inside of my constant, I'm actually going to set this alpha value based on the number of particles. So I'm going to say the alpha I want to be 1 over the number of particles. So now each one has only a value of 1 over 144. Okay, so we're getting an error. That's okay, because we probably need to turn on blending under the common value of the material. And I'm also going to turn off depth test, because I don't need to care. Like they're all on the same depth level. Okay, so if you zoom in far enough, you can kind of see a little faint something happening there. And if I do my favorite A and N to look at the normalized values of each channel, I can see, okay, great, I've got things rendering, but I'm also getting this sort of noisy stuff, and the values are really small. What can we do? Okay, first of all, actually, I'm going to change this render. I'm going to make it a 32-bit float. It smooths things out, but you notice I'm still getting these little grainy parts. That's because under advanced, I need to turn off dithering. Now I've got nice smooth force happening, or a nice smooth value coming out here. And I don't need these blue and alpha channels actually, so I'm going to do 32-bit RA or RG. Okay, that is what I want. I want the overall, with all the particles, I want to know where all the forces are between each of them. Okay, and based on this, I'm also going to turn this on for a second. I don't love using the background render, but I'm going to use it for now. I'm going to tweak this a little bit. So I'm going to make my circle a little bigger, because I want the influence range to be bigger. But maybe I want to push the particles away from the center in a smaller radius, so I can go to my repel ramp and bring my period down. Also, one thing I kind of failed to do here is instead of having this sort of linear look to, let's ramp using ease in and out, and then even further I'm going to add this to be exponential as well. So let's add a function. Let's bring in another one of these so I can visualize what it's doing here. And then I'm going to say for the function, I'm going to do this input times exponent. It's kind of similar to what I was doing before. That doesn't make a difference. Never mind. We're not going to do that. Sorry about that. Okay. Where are we at now? So we've got our force. And I think we're going to leave this there for now. Okay. We're getting a good set of data here coming out. Okay. So that's my push-pull. And I'm going to show the normalized version because it gives me a good view. Okay, so let's assume that's good enough for now. Let's go ahead and add our follow. So I'm going to copy and paste this actually, because I'm going to use a lot of the same stuff, and I'm going to call this follow. And for follow, instead of having this sort of the same sort of force being added for each particle, I want to add a gradient around each particle of what that current particle's vector direction is. So that way, as they sort of all add together, wherever a particle is, if it has an overlap of a bunch of different things around it, it's adding together those around it and using that as the new direction it wants to go. So for this, I need that vector information. So I'm going to add another input. I'm going to bring in the feedback vector information. And then I'm going to add this to a null. Call this vec. But this is going to actually be what I use to overwrite the color information in my instance. So I'm going to bring this into my color information, replace the R into the G, and then I want to use a ramp again here to make sure that the influence is based on the distance from the particle. Let's see. So what does that look like? Let's get rid of this add. And then I for sure want to use the function here. So let's add this to there. And then if I do this exponent, there we go. So now, I want a very small influence far away from my particle and a larger influence when I'm closer as far as how much it will follow. Let's maybe do this like a 4. Okay, I'm still using that same, actually no, I'm not. I'm going to take this slope out, take this limit out. I think that should be good. So we want a nice gradient to where the value in the middle is going to multiply by what the color is, and it'll drop off as I get farther away. And let's actually make sure our black is actually, let's change it to white and then drop the alpha. So we're getting, let's do, instead of 32-bit mono, let's do 32 mono plus alpha. There we go. Okay. Feeling all right. Okay, so let's look at what we have coming out of this. So if I turn this off, sometimes, so I love this alpha normal thing, or sorry, activate and then normalize, like hit A and N to get this view. But also sometimes I like to go in and say to limit and then normalize to get a combined view of what this looks like. This is just kind of my previs to make sure I have an idea. So you can see as this visualizes for each particle which direction they're facing. And so if I'm a particle sitting on top of this, I'm going to get influenced by my own direction, but also anything around me, so that it starts to add together to add a follow effect. Okay, so now we've got our push-pull and our follow. And I want to combine these, so I'm going to add these to a composite. Make this one a little bigger because this is kind of my big brain where everything happens. And I'm going to add those together. Okay, let's do A and N on that again. So we have our two influences should be coming together on this. Another thing to notice here, okay, so this value, like it's being normalized to negative 0.007, and this one is being normalized using 0.03. So this value is a lot smaller right now. So let's go in here and see if we can tweak that a little bit, just to try and get them a little closer together. So I might just add in a math here. Let's see, is this what I want to do? Yeah, let's add this in here, and then we can adjust this multiply amount on the math to kind of pull things closer or further, or push things closer or further away based on the values. And let's multiply this by like 3 right now. Just see, bring ourselves up a little bit higher, a little bit closer. Okay, so now we can see there's influence from both kind of showing up in here. Great. Let's just keep that for now. And then let's see, coming out of our comp, so we want to have this influence our position. So we're going to add this force to our position, but we want to do it based on, this is the position data. This is where in the simulation they're going to exist. So I need to do a remap. So I'm going to remap this using, this is my UV data. And then I'm going to use the resolution of UV. And what else do I want to do here? I also want to add that. So I'm going to add that particle data to this influence data, or this force data. And coming out of this, I know I also want to add a math here, and this is going to allow me to set my speed. I'm going to set the speed under this multiply for math. Okay, let's visualize these as well. So we know this is our simulation data, this is our UV data, or yeah, the UV data for our new positions. Velocity, I guess that's what this is. Okay, so nearest pixel. Okay, we're getting closer. Let's see. I also know that as these get pushed around, they're going to go off screen. So I know I'm going to want to limit to um, to loop it back around to the other side. So let's add loops. Let's just go from 0 to 1. Then let's add a null. Call it to position feedback, and drag it to the feedback. Okay, getting something. It's a good start. Okay, so now we need to mess with our velocity a bit. So the velocities aren't changing. Let's see, why is it all going one direction? Our noise is going both directions. All right, we'll get to that in a second after we work on our velocity as well. So every time we come back to this feedback, I want to make sure it's updating based on this velocity. I want it to be moving towards whatever the influences around it are. So I'm going to add this to my vector. And then because I know this is going to be constantly adding, I want to sort of normalize it. So I'm going to add it to a limit. And I might instead want to do a dampen instead of a limit here, but for now we'll just clamp it. So we'll clamp it to -1, +1. So like the maximum velocity that we can get to in any particle is going to be -1, +1 in red and green. Okay, and then let's take that into a null and say to vec feedback. And that's going to get dragged back to our vec feedback. All right, so where are we at now? Let me check something real quick. Right, okay. I'm actually going to add this math after the remap. That way I can use it on both of these. Because I don't want to bring in the simulation data. Okay. And then so let's see, our current speed is way too fast, so let's actually use this speed here and go into our constant. Let's bring that down quite a bit just so we can get looking at something. Okay, it's good. Getting movement, but obviously as we see, everything kind of devolves into moving up and to the right. So we'll fix that. What else do we need to do? Let's go ahead and make our final rendering output too, so we can start to visualize what that's going to look like. So let's drag it out here a bit so we can make sure we have space. And then I'm going to call this my position data, and let's start building our instancing for our final output. So I'm going to use a circle first to make this. I'm going to take it down to 3 to make a triangle, and shrink this down to like 0.04 and 0.02 maybe. Let's see, what's that? Yeah, okay. So I've got this nice triangle pointing right. I'm going to bring that into a geometry, bring in a constant, make a camera. Let's see this one, and then render. So this camera is also, I'm going to keep a perspective. I know I'm in the between 0 and 1 range, so I'm going to move it 0.5 by 0.5 to center it there. I'm going to make this a vertical screen, so 720 by 1280, and drag it to an out. And this is the thing I want to view. I'm going to drag it to my top left here as my sort of preview. Okay, that's actually looking a little small, so let's see if we can pump this up a little bit. Yeah, okay, that's fine. Okay, so let's do instancing. So we go under our geometry, turn on instancing, I'm gonna bring in our position. It's gonna be RNG. Okay, so I've got my particles showing up. I'm obviously zoomed out too far, so I'm gonna go into my camera and resize this to be sort of vertical looking too, so it gives me a better position. Oh, you know what? My original number is probably better here. Or even too big. My camera was zoomed out, that's why it looked too small before. Okay, so let's say 0.2. Sure, let's say 0.2, 0.1 for now. Okay, so I've got my positions all right, but obviously they're not pointing in the right way. I want them to point towards where they're going. So I'm going to use this math. That's going to be the vector of the influence, and I'm going to use that to tell my points where to point to. So I'm actually going to bring that into a read order, and that's because I'm going to be using I'm going to bring it to a null first. I'll call this rotate 2. And rotate 2 can be a little confusing. Sorry, I'm getting ahead of myself. The reason I brought it into this reorder is because I want to turn it from an RG into an RGB, and I'm going to do that by setting my blue value to 0, and just let's go ahead and do 32 RGBA. So now this is a RGBA with the blue value of 0. That's because I'm going to go in my instancing in the second tab, in this rotate 2 value, I'm going to bring in my rotate 2, and I need R and G and B, because this calculation requires, even if B is 0, it still requires me to have something in there. And this direction, it's asking you, whatever the thing you wanted to rotate to, like where's the point that you want to rotate to, like where is the original point, like where's the pointing direction. So right now this is pointing on the x-axis, is pointing forward, so I'm going to say x plus. Okay, now if I start over, you see my little voids here, my particles are all pointing in the direction they're moving. Okay, so this is a great start. So what else are we missing here? So things are flowing. I want to what else do I want to change? Okay, so I know another thing I'm going to want to add is I'm going to add some turbulence to this. So I'm going to drag out of my follow into a noise, and I'm going to make this not monochrome. I'm going to make it RG, 32-bit RG, and I'm going to because I'm just going to add it straight to this comp. Like you can see here, like if I do the normalize again, I don't want this 0.3. That's pretty strong. So I'm gonna bring this value down, and I'm gonna offset it from 0, so I get negative values as well. So first I'm going to 0, and then I'm gonna bring this value down. So I'm getting a closer value to what this is. So even 0.01 is maybe, well, let's try that and see what happens. I'm loving this normalized value stuff. Okay, so yeah, it's normalizing to this 0.02. That's about the same as what the follow amount is. I want my turbulence to be a little lower though, so let's do 0.05, because that's gonna randomize things a little bit more for us, so that if particles kind of get stuck in a row together, that they don't that they separate from each other a little better every once in a while, and they kind of feel like they've got their own mind. Because of that, also I'm gonna just to add a little more randomness to them, so it seems like these things are a little more alive, I'm going to also, here in my, where I'm calculating my vector feedback, I'm going to also add a little bit of noise here as well. So I'm going to add a noise. I'm going to say I do want input plus noise. I'm going to offset it from 0, and I want it to be like 0.08. Don't want it to be monochrome. And let's go nearest pixel. All right, so this should give me a little kind of like little extra sort of bump around. I'm going to actually animate this as well. So let's go to simplex 40, and let's bring our period pretty much all the way down here, and then apps time.seconds for our animation. We don't want to animate this too quickly, so they're not sort of being too random on their own. Okay, so let's see, what else do we want? All right, let's go ahead and do some of our post-processing, because I think we've got a good start here, and we might come back and tweak some values. Oh, I just changed my camera. Because I know there's one more thing I want to do to kind of keep my particles in the middle, I think. So post-processing, okay, so I want to get back to this sort of cell sort of look. So I know my directions are all working now, so I'm going to actually change this this arrow to be a little bit bigger, so I want to make them sort of rounded off, but not too much, so I'm not using too much geometry. So 10 divisions is probably good. And then because these are little cells, they're going to have different sizes, so I'm going to use off of my position, I'm going to add a noise, and then add it to a null, and call this scale. Now this noise, I do want this to stay monochrome. I only need to be 32-bit mono. And then, okay, I want to animate this as well. So I'm going to do simplex 4D transform apps time.seconds over 13. And let's see, the output, I only want the noise. Let's make these nearest pixel. Okay, so this should be slowly moving up and down. Let's add that in and see what that looks like. We can tweak it afterwards. Okay, grab it. Scale, and these are all the R value. Okay, so now my cells are slowly kind of growing and shrinking. Maybe I want them to start at scale of 1 and not scale quite as much. Well, maybe we'll scale them a lot. Let's see. Let's stick with that for now. Okay, now I want these to look like they're sort of moving through water and look a little wiggly, and the way I'm going to do that is putting this through a displace. So drag this into a displace. I'm going to then get a noise coming off of this just to use the resolution. So I'm going to only grab the noise. And I'm going to set this to 32-bit RG, because that's what a displace cares about. Turn off monochrome, so I get this nice red and green mix. I'm going to add that to my displace. It's going to look terrible at first because I need to go on my displace and change the vertical source to green. My midpoint, I'm going to say 0, and the displace weight can come down quite a bit. So let's see, start getting something sort of wiggly looking in here. So yeah, we're getting that sort of like watery look. Let's go down to 0.01. And then we can also play with the kind of size, this size of this, so they don't look like they're moving too much in the same way as each other. Okay, I'm going to leave it at that for now. I'm going to drag it in. Oh, sorry. I'm going to drag it into my output here, so it's updating on what I'm seeing. Okay, and then to do my cell look, I'm also going to add an edge. This will add it so when you get nice little blobs that come together, it's almost like they're joining cells. And then I'm going to give that a color or something a little brighter, because in the future I'm going to use a little glow to highlight that. And then I'm going to add a constant. Oops, not a convolve. Constant. Give that a little bit of a more intense color, and I'm going to add this over the top. Add it to my output. Okay, so there we're at this, and then I'm going to also add this kind of flowy background, and I'm going to use my optical flow feedback method for that. So in tools, not my tools, I'm going to go into tools on the palette, and then find my optical flow, bring that in, and then use this what's after the displace, or use my displace, and let's make some room here. Okay, so I've got my optical flow. I'm going to bring that into a feedback. I'm going to bring that feedback into a displace. I'm going to displace it by itself, and then I need to update these values to be green. The midpoint is 0. My weight I want to be 0.001, and I'm going to bring that into a level and also a blur. Oops. So the level is going to be what fades me out. Actually, instead of a level, I've been liking more using a math and just doing multiplying by like 0.99. So it goes towards 0. And then the blur is going to be what sort of spreads things out, gets that liquidy effect to it. Okay, I'm going to bring that into an add, and add that to the original optical flow, and drag my add back to my feedback. So now I'm getting this really nice, should be getting this really nice fluid background. And since I'm just using this for visuals, there's a bunch of negative numbers in here. I'm going to make sure those get visualized as well. So I'm going to go into a limit and say positive only, and you'll see now I get sort of all directions. So left or right is both going to turn red or not red. And then I'm going to use this I'm going to put it into a monochrome. and then into a constant to then add some color to it. Let's pick like a deep, darker red, maybe actually brighter than that. And then let's bring our out way over here, and then put our little cells over our background. Okay, so now we're getting this cool fluid thing. We can adjust things like maybe I don't want to blur it out quite as much. Maybe I don't want it to fall away quite as much. Also the displace, instead of holding on the ends, I'm going to set it to 0 so I don't get too much getting pulled off the edge. All right, what are we looking at? Seeing too much jagged edges from my geometry, so I'm actually going to bring up my circle divisions up to, let's say, 15 or 16 here. Okay, that's looking pretty good. I know I always like adding a little bloom in here as well. It makes them look a little more interactive when they get close. So let's see if I increase the intensity, but I like tweak my bloom fill a little bit. Then as things get closer to each other, so merging. Let's see if we can zoom out. Oops. So we can, because we're not in an orthographic view, we could do a little angle on this camera if we really wanted. Let's bring our scale back down a little bit. These guys are getting a little bigger than I really care. Now if at 1, they start from 0. Okay. All right, I think I'll probably stop there for this. But yeah, so this whole idea of getting a flocking algorithm out of pre-rendering out some instancing and creating this sort of force texture to then add to our particle locations, to sample from to add to our particle locations, I think it's a pretty cool new way to do things. Yeah, if you have any other ideas of how we can get this effect, I'm definitely curious to hear about it. Yeah, I'll leave it at that, and thank you for watching, and I'll see you at the next one. Thanks for watching this tutorial. Just a reminder that this project file, along with all of my other project files for all my previous tutorials, are available to my Patreon supporters. So if you click on that link, it definitely supports me and it helps me to keep going on my research and learning and my ability to help make these tutorials. Thank you so much.